writing down about.
They've never.
Polynomials. And we have done a lot with them so far in the past couple sections. We've talked about, you know, your maximums and minimums, your zeros. We've learned how to factor those polynomials if you have the first zero. So we're really just continuing with that idea today. The new piece, we have this conjugate zeros theorem. Tells us in a real polynomial. That means you're looking at a polynomial and all the coefficients are real numbers. There's no i's in it anywhere. So all the polynomials we've looked at so far have been real. If you have an imaginary zero, its conjugate also works. So what this is telling us is those imaginary zeros are going to come in pairs. If, for instance, 1 minus 3i works as a 0, 1 plus 3i will also work. So if I give you an imaginary zero, then I'm really telling you 2 of the zeros. The conjugate will automatically work. So our first example, we're just going to write a polynomial to meet these requirements. So if I want to find a polynomial that has zeros of 3 and 4 plus I. I just gave you 2 zeros. But if 4 plus I is a 0, based on that theorem you just wrote down, what else has to be a 0? Okay. So there's really 3 zeros here. So it's degree 3. We're going to write the polynomial, and I'm just going to put it in factored form. So if 3 is a 0, what would my factor be? X minus 3. Okay, with the i's, when you do your zeros, you always do x minus those. So in this one, if I distribute my negative, you would have x minus 4 minus I. With the 4 minus I, if you subtract that off, you get x minus 4 plus I. Okay, so really, the only difference, your 2 imaginary zeros, is the sign on the I. One's positive and one's negative. Does it matter what order you write those things in? No, you just have to have those 3 parentheses. Alright, you guys take a second and try B. I've given you 3 zeros. So figure out if you need any more, and then write your factored form for me. If 5i is a 0, what else has to be? Negative 5i. The conjugate just changes the sign on the imaginary part. Okay, if negative 1 minus I is a 0, what else has to be? Okay. So how many parentheses will I have? 5, right? We also have that negative 2. So since negative 2 was a 0, you always do x minus the 0, so x minus negative 2 makes x plus 2. We had 5i, so x minus 5i. You can put them in any order. If I did my negative 5i, x minus negative, so x plus 5i. Okay, for the negative 1 minus I, if I do x minus that, you get x plus 1 plus I. The last one, if you did x minus the negative 1 plus I, you get x plus 1 minus I. So the sign on the I changes with this. Any questions?
Where are you getting x from?
When you write the factored form, just like what you did on our quiz the other day, or yesterday. when you had your zeros of like -2, 3, and 4, if I said write the factored form, that's when you put the x's with each of them. And it's just always x minus your number. So we would write it x plus 2, x minus 3, x minus 4. You did it on your quiz yesterday. So the polynomial is like the original thing that had the x's in it. And we're kind of working backwards here. I'm telling you the zeros. I'm telling you everything that you can plug in to make it equal 0. So you're trying to write the original problem again. So it's just x minus each of those numbers. If we really wanted to, I mean, we could FOIL all this stuff out and we would get like x to the 5th minus 3x to the 4th plus 2x cubed, and we would have that normal looking polynomial. But I just don't think it's worth our time to do that. We're just going to leave it factored. Other questions? Yes?
Why did you have to write 2, like you did x plus 2,
Mm-hmm.
and then you went on to x minus 5i, and you also did an x plus 5i? Why didn't you do that for the x plus 2?
It only is with the imaginaries that they come in pairs. Basically, when you FOIL that, if you want the i's to cancel out, you have to have 2 of them, so you get an I squared. So it'll always be the case, if it's just a real number, it's only that number. But if you have an I, they come in pairs. Other questions? Let's do some more writing the polynomial, but I'm going to change it just a little bit. So I want a polynomial of degree 3. So it's a cubic. I have 3 parentheses. That meets these requirements. Part A. My zeros are -3, -2, and 5. I'm giving you an extra requirement that f of -1 equals 6. Okay, first of all, did I give you any imaginary zeros here? No. So do we have to add any more to our list? No. If I'm writing this factored form, if -3 is a 0, what would my factor be? If -2 is my 0, we would have, and if 5 is my 0, we get, okay, so we've used this requirement. Now I gave you something a little bit different. F of -1 equals 6. That means when my x is -1, this whole thing equals 6. I told you in the beginning it was degree 3. So can I have any more x's in this problem? No. The only thing that could be different is there could be a number out in here. Like I could have a 2 or a negative or something out in front. For a second, let's just call this A. Okay, A is just representing a number. Now we're going to find out what that A has to be. So if I plug in a -1 for all my x's, this whole thing has to equal 6. So -1 plus 3 is 2. -1 plus 2 is 1. -1 minus 5 is -6. So if I multiply those, we have a -12a equals 6. To solve for a, we would divide that -12 over. And my a is a -1/2. So that means the polynomial that meets all the requirements I gave you has a -1/2 in front. And then this would be our final answer. 1, and then 2 times 1 is 2 times negative 6 is negative 1. Questions on what we did right there? Again, I had to find that A because of this extra requirement. I essentially gave you 1 point that had to be on the graph. So we had to figure out what our coefficient was to make that true. I'd like for you guys to try B. What does a multiplicity mean? So since 4 is a 0, you always do x minus your 0. A multiplicity just tells you your exponent, so multiplicity of 3 means it's cubed, so there's all 3 of my zeros. Now my extra requirement. F of 2 equals negative 24. So there could be a coefficient out here. We have to find that. When my x is 2, this equals a negative 24. So 2 minus 4 is negative 2. Negative 2 to the third is negative 8. Divide by negative 8, and our A value is 3. So our polynomial is 3 times x minus 4 cubed. Any questions on that one? So the homework tonight is going to have 3 types of problems. We've done the first 2 types, just writing the polynomials. The final type kind of goes along with what we have been doing. So I'm going to give you a polynomial and I'm going to give you the first 0, and I want you to find the rest. The difference is, before today, all of your zeros have always been real numbers. I might say 2 is a 0 or 3 is a 0. Today I'm giving you an imaginary 0. So we have to factor this when we have an imaginary 0. So on your quiz or on your homework, when I gave you the first 0, what was your first step? You plugged it in, did the synthetic with it, right? That's what we're going to do here. Since 3i is a 0, I am going to do synthetic with a 3i. Leave yourself a little more space than you're used to. You don't want your coefficients to be too close together. So we have a 1x to 4th, negative 1x cubed, 10x squared, negative 9x, and positive 9. I don't need any zeros. We don't have any missing powers. Okay. First step to synthetic is what? Bring down the 1. So when I multiply 1 times 3i, that's 3i. Are these like terms? No. So when I add that, it's just negative 1 plus 3i. The next step is to multiply. So we take the 3i times negative 1 plus 3i. When I do that, if I distribute, we get a negative 3i and a positive 9i squared. But what do you know about I squared? Okay, so this is negative 3i minus 9. Add like terms, the 10 and the negative 9 gives me a positive 1. And we still have that negative 3i. Multiply. So 3i times 1 minus 3i. If you distribute, 3i times 1 is 3i. 3i times negative 3i is negative 9i squared, which turns into, so we get 3i plus 9. If we add those, the 9's cancel and we just get 3i. So 3i times 3i is 9i squared, which is -9. We add those and get 0. Alright. This looks kind of ugly. We have all these i's in there. Am I going to be able to factor nicely if something has i's? No. But if 3i is a 0, what else is a 0? Negative 3i. So what we're going to do now is synthetic a second time. This time the number in my box will be a negative 3i. And we're going to divide the answer we just got. Okay, so this last one was the remainder. We're going to leave off that 0. And we're going to divide this polynomial. So we have the 1, negative 1 plus 3i, 1 minus 3i, and 3i. This one should be a lot nicer. All the i's should disappear this time. So the 1 comes down. 1 times negative 3i is negative 3i. When you add those cancel and we just have negative 1. Negative 1 times negative 3i is positive 3i. Add those, the 3i's cancel and we get 1. 1 times negative 3i is negative 3i. Add those and we get 0. So that's our remainder, our constant, x and x squared. So we have x squared minus x plus 1. What do we do from here? Box method. Okay, what multiplies to positive 1 and adds to negative 1? Nothing. So if we can't factor, what do? Quadratic formula. We've had to do that a few times so far. So opposite of b would be a positive 1 plus or minus the square root of b squared minus 4ac all over 2a. So negative 1 is squared is 1 minus 4 How would I break down the square root of negative 3? So our directions were to find all the complex zeros. Complex just means they might have i's, they may or may not. It was a degree 4, so we should have gotten 4 of them. And we have. This is 2 right here, 1 plus I radical 3 over 2 and 1 minus I radical 3 over 2. The other 2 were positive and negative 3i. So it's the same process that we have been doing. It just can look a little bit different if I give you i's in your problem. Any questions there? I want to do one more and then I'm done for today. So on the homework we're going to have several like this where I give you the first 0. I may or may not give you an imaginary 0 to start with. You know, a lot of them I may give you a real 0 still. But whatever that is, whether it's real or imaginary, that's where you begin your synthetic division. So I'm going to start with the -2 in the box, or sorry, -2i. What would my coefficients be?
1, 0,
Make sure you have those zeros for the missing power. Okay, 1 comes all the way down. 1 times -2i is -2i. 0 plus -2i is -2i. Then we multiply. -2i times the -2i makes positive 4i squared, which is 3 plus -4 -1 times -2i, 0 plus 2i is 2i. Multiply, -2i times the positive 2i is -4i squared, which is, and we add those and we get 0. Are we ready to factor this nicely yet? No. What am I going to do synthetic with this time? Bless you. And my coefficients, you don't use the remainder, so you just bring down the 1, -2i, -1, and positive 2i. So 1 comes down. 1 times 2i is 2i. Add those and we get 0. 0 times 2i is 0. Add and we get -1. -1 times 2i is -2i. Add and we get 0. So there's your remainder, your constant, your x, and your x squared. So we end up with x squared minus 1. Can I factor that nicely? Yes, I don't need the quadratic there. So that's the difference of squares breaks into x plus 1, x minus 1. So my directions were to find all the zeros. Okay, so we had a -2i, we had a positive 2i. What would make x plus 1 equal 0? And x minus 1? So it was a degree 4, we should have 4 zeros, and we do. Any questions there? So that is my stopping point. There is a handout posted in Classroom that's 10 questions, basically 3 types of questions. The first example we did, where just writing a polynomial with the zeros. Second one's where you had to write the coefficient with the polynomial, and then these third, finding the others.
How did you know there was 4 degrees?
Because the original was an x to the 4. So that tells us our degree. When you get down to the last section with finding the remaining zeros, there are some that don't factor nicely, so make sure you know your quadratic formula. You'll have to use that several times on here. So you've got about 20 minutes. I'd like for you